Good morning, class. So we are going to have our review now. Okay, we have this one. We have angle F, we have 50 degrees, we have 80 degrees, we have angle G and angle H. So here we have a cyclic quadrilateral, but we are not going to use our cyclic quadrilateral. We are going to use the subtended angle theorem, and we are going to use our fingers to trace the angle, so you will not be confused. Okay, so let's have 50 degrees. So let's start here. So from here, let us trace. Okay, I'm going here, and my right finger will trace here. Are you following? And then my left finger will go here, and my right finger will go here. Therefore, what can you say about 50 degrees and angle G? They are equal. So you write here 50 degrees. Easy. Okay, let's have the 80 degrees and find angle corresponding to 80 degrees. So let's start with the 80 degrees here. So I'm going here, and my left finger here. I'm not going to return back, and then trace here to reach this point here, and my right finger will trace there. Therefore, this angle F and the 80 degrees, they are equal. So I'm going to put here 80 degrees. But what about H? We don't know about the H yet. What is this shape, class? This one is a triangle. In any triangle, the sum of the interior angles, this, and this, is always equal to 180 degrees. So if we have already the 80 and the 50, we just add these two and then subtract it from 180 degrees. So 50 plus 80 is 130 degrees. So we just have 180 degrees, the whole thing, minus 130 degrees. So here also we have a 50 degrees here. So this one is also 50 degrees. What theorem is this? This is the subtended angle is 1/2 only of the central angle. So what do you call this one? This one is central angle, but not for the subtended angle here. So if this is 1/2 of the central angle, then don't put the 70 here, because the central angle of the subtended angle A is not this 140 degrees. But where is it? This is the partner. That is the partner. That is the central angle of this A. And this A is 1/2 only of that central angle. So we have the 140 degrees here. So what is the measure of the reflex? Class, this one is 140. This is the obtuse angle in the central angle. And the other one, which is greater than 180 degrees, we call this one reflex angle. So it is more than 180 degrees. So what is the measure at a point? The entire angle there. It is 360 degrees. So how can we find that one? We subtract the 140 degrees from 360 degrees. So I'm going to put here 360. That's the angle at a point. And then we subtract 140. 0, 2, 3 minus 1, 2. So 220 degrees. So this one is 220 degrees, and the subtended angle is only 1/2 of that. So when you divide 220 by 2, then we get the A is 110 degrees. Okay? Okay, let's have this figure here, class. Class, this one is a cyclic quadrilateral. Quadrilateral means we have 4 sides, and the vertices of our quadrilateral, they lie on the circle. We have the vertex here, here, and there. If we have 4 sides, we have also 4 angles. And what is the relationship of these angles? The opposite angles measure 180 degrees if we are going to add the opposite angles. Okay? So where are the opposite angles here? This is the opposite of this one. It's not the opposite, because this and this, they are connected with a side here. If they are connected with a side, they are not opposite. So the opposite of 40 is A. The opposite of B is 130. Okay. In other figure class, take note and prepare for the opposite angles, because sometimes it is not easy to determine which is the opposite side. So careful of that one. So if the sum of this and this is 180 degrees, what will you do to find A? You subtract this one from 180 degrees. So 180 degrees minus 40 degrees. So this one is 140 degrees. What about the B and the 130? If you add them, the sum will be 180 degrees. So what will be the measure of B if the other angle is 130? So that is 180 degrees minus 130. So your B is 50 degrees. Okay, so class is also a cyclic quadrilateral, but we have an extra line here. We call that alternate segment here. Now, apply class this one, and you have the interior of one of the angles of our cyclic. The opposite of this one, which is C, is equal to 130 degrees without computation. So you can say that this one, not this one class, because this one is not the opposite of this angle here. This one, no, it's not the opposite. It's the opposite, which is equal to the exterior. Actually, this one is exterior angle of our cyclic. Exterior means outside. So this is also 130 degrees without computation. Okay, what about the B? So if you want the B, you subtract 130 from 180, because this B and the C, they are supplementary, meaning their sum is 180 degrees. So 180 minus 150 will give you 50 degrees here. Now, without choosing that one, can you see this one class? It's a straight line. When you see a straight line, it measures 180 degrees. And then when you have already 130, how can you get the B? Subtract this 130 from 180 degrees. So that will give you also 50 degrees. But this one and this one are equal. Remember that one, without computing it. Okay, let's check this one. This one class is just like this one. Okay. But here we can see easily the subtended angle here, the L, and the central angle. So we can easily find L. What is the measure of L? L is 1/2 only of the central angle. So 1/2 of 140. So angle A here is 70 degrees. Half of 140 degrees. So after that one class, what do you see here? You will see here a cyclic quadrilateral. If you remove this one, You see a cyclic. 1, 2, 3, and 4. Now, this angle L here and that angle M there, they are opposite angles of our cyclic quadrilateral. Now, what can you say about that one? They are, the sum of the angles is equal to 180 degrees. So, if you have 70 here, what is the measure of angle M? That is 180 degrees minus the 70 will give you 110 degrees. Okay? Okay, the last one. We have here, find angle X. So if we are going to use our tracing here, and then go there, this one is the 70, not the X. So how do we find the X? So you know this one plus this one is a center. Okay. When a line or a chord passes through the center, it is the diameter. So this one is the diameter of our circle. When you see a diameter, find a triangle because the triangle is a right triangle. So do you have a right triangle here? And this one is the hypotenuse of the triangle. Yes. Remove this one. Can you see this? First, here we have a right triangle because we have the hypotenuse, a chord that passes through the center O. Therefore, this one is 90 degrees because that is a right triangle. Now, if one of the acute angle is 70 degrees, how will we find the other acute angle? We just subtract this 70 from 90 degrees. Because the sum of these two acute angles is 90 degrees. So 90 minus 70, this one is 20 degrees. Now you can use this one. You trace it. So the 20, here, okay, there, and then here, and then it's there. Therefore, the value of X is 20 degrees. Okay, let's have this figure plus. And let's locate the center of our circle. So it's not even. Therefore, this line here is not the diameter. Okay, 40, 35, 70, X, Y, Z. Now let us use our tracing fingers because you can see we have a subtended angle here, here, and there also. There are so many subtended angles here. We don't have central angle. So let's start. Let's find the Y if you have value for Y. So there, here, here. Okay. For Y is 70 degrees without computation. Okay, let's have X. So X is here. So I'm here. My hand is here. I'll go there. This finger will go there. Oh, it's 40 degrees. So this angle here is 40 degrees. What about angle Z? So angle Z, let's trace here, and here, and here, but I can't go here because there is no line here. So we cannot find the Z. Okay, we have the 35 here, we have the Z here. Can we find this angle here? Okay, let's start here. The 40 and the 70. This is a triangle. So we had 40, 70. This is 110. Okay. 70, 40, 110. Subtract it from 180 degrees. So we have 180 degrees. And we have 70. So this angle here is 70 degrees. Now, what do you see here? A straight line. If this one is a straight line, it measures 180 degrees. So how do you find this one? It's 180 minus 70. So this one is 110 degrees. Now, can you find the z now? Yes. This one is a triangle. The sum is 180 degrees. And we have the 35 and the 110. So let us add the 110 here and the 35 there. So we have, let us add, we have 5 and then 4 and 145 degrees. Now how do you find the z? We subtract this from 180 degrees. So let us do that one here. 180 minus 145. So we have 5 here, we have 7 minus 4. So this one is 35 degrees also. So we have x, y, and z. Okay, let's have this video. This one, oh, we have the center of our circle. Now when you see the center of our circle, it's either you look for the diameter and the radius. So here, oh, we have the diameter. Therefore, look for the triangle. We have a triangle. So you can easily put here the 90 degrees because that triangle is a right triangle. Now we have the 40 degrees here. So, okay, this is for x. The x and the 40, they must equal to 90 degrees because we have already 90 degrees here. Total of 180 degrees. So 90 minus 40 degrees is, our x is 50 degrees. Okay, let's go further. Now this O to A is radius. O to B is another radius. And the radii, these two radii are equal. If they are equal, these two sides are equal, and we have a triangle. What's that? That's an isosceles triangle. And when you have an isosceles triangle, you have the base angles which are equal, and the other angle, which is a third angle, is called the vertex. Now here, what is the 50? That is the base angle of this triangle, and the other base angle is this one, which is 50 degrees. If you are required to solve for this angle, how do you call that angle? Angle AOB or angle BOA. So how do you find that vertex angle? We add 50 and 50, 100. 180 minus 100, this one is 80 degrees. Now, can you find this one? This angle here? Yes, a straight line. So what is a straight line? 180 degrees minus 80. So this one is 100 degrees. Radius also, radius 40. So this one is also 40 degrees. 50, 40, 90 degrees. That is how to solve. We are going to find all the angles in this video class. Okay, let's find the center. Okay, we have the center here. Oh, now what is this? This one is the radius. This one is the radius. So what is the 50? That is one of the base angles here. So if that one is the base angle, this one is also our base angle. And if you are going to find the vertex angle, this angle, it's easy. It's 50, 50, 100. 180 minus 100. So this angle here is 80 degrees. If you have letters here A and B, how do you call that? It's BOA or AOB acute. The other one here is the reflex. And how can we define this reflex angle? It's 360 degrees minus that 80 degrees. I think that's 280 degrees. That's the reflex angle AOB. Okay, let's have this one. Okay, center. We have a center here. Yes. Just go on. This one is our O. So we have our diameter here. We have a triangle, and this one is the right triangle. Okay, we put the symbol of right triangle here. This one is 70. What is the measure of D? That's 90 minus 70 is equal to 20 degrees. Finish there. Now, we have a subtended angle, we have a central angle. What is the relationship of the subtended angle to the central angle? The subtended angle is 1/2 only of the central angle. So 1/2 of 100, so our x is 50 degrees. It's half only. Okay, the last one, we have x and y, we have 42 degrees here and 36 here. So if you are confused which is 42 and which is 36, use your fingers. Finger tracing x. Let's have x here, trace here, go there, go there, go there. So it's 42. Okay, x is 42 degrees. What about the y? You are sure that one is 36 degrees. But let us trace y here, y there, okay, there, and here. So our y is 36 degrees. Okay, class, good luck to your long test.